Hi. Okay. So it is our next lecture on the lecture series vector for dumb, right? So these are next part, part number probably the 8. Okay. Vectors for dumb, right? These are vectors for dumb. Vector for dumb, part 8. Okay. So as I had introduced in the previous lectures, the algebraic representation of the vector, how to represent a vector with the unit vectors along I, J and K, something like that. And then there are previous lectures, the geometrical representation, how to represent a dot product, right? Right. The dot product of geometrical representation I have introduced to you I think the past in the part 6 lecture, right? So just recalls our part 6 lecture and the part 7, the last lecture what I did. The part 6 lecture is a geometrical representation of dot product. It is a very simple thing. It was, if you have a vector like A and a vector like B, right? And the theta, the angle in between A and B, right? And if you lit a candle there, then the shadow of A will be obviously it is the shadow length of A, right? So if I name it is a O is a point P, it's a point Q, and if it's a point R, so OR actually the length of the shadow, right? Length of the shadow, right? So obviously it will be the length of the shadow. If you lit a candle just perpendicular with a vector B, the perpendicular with the straight line, the length of this stick just is a stick, right? The vector A is a stick, so obviously the length, the shadow of this A on the vector B will be this OR, right? It's a very simple case. Just imagine the length of the shadow, right? Or you can call it a projection, right? Because you just project the vector A on the vector B, right? Just project. If you lit a candle, if you lit a candle, just a perpendicular to that vector B, the shadow is actually, if it goes, this is a projection, right? If you project the vector A on this vector B, so the OR, the length of the shadow, you can call it projection of A, right? Just the name, projection, is the length of the shadow, projection. Just project this thing from here to this line, right? Just this a projection, length of the shadow, right? If you just project this thing from here to this line, right? The length of the projection. Okay. The projection, you can call it the projection of vector A along B. No problem. Along B. Right? Length of the shadow means the projection. Right? And then all of you know what will be A dot B actually. A dot B goes to modulus of A, modulus of B, the magnitude of A into the magnitude of B into cos of this angle, right? Cos of this angle, obviously. And just if you juggle here, modulus of A into cos theta into modulus of B, the A dot B. can juggle, right? Because it's a normal product and you can juggle with cos and b, a, you can juggle, right? So it is your length of the shadow, right? Modulus of a cos theta, because it is a a, so it is a OP, that means magnitude of A here is the length of this thing. So obviously cos of this theta will goes to base by hypotenuse. All of you know modulus of a cos theta is actually length of the shadow. So obviously the modulus of A goes to, the modulus of a cos theta, that means shadow, length of the shadow, that means the projection of vector A along B will goes to, just translate here, vector from here to there, right? Just transfer. So you get modulus of, the vector A dot vector B by magnitude B, right? This is a simple equation. It is actually a projection, right? Projection. Okay. Projection of vector A along B, right? That means the length of the shadow, right? It's a very simple case. The length of the shadow, that means a projection. This is actually modulus, the vector A dot vector B by the magnitude of vector B. And you can write A dot B vector by magnitude of B. It's very simple. Just shift from overall division to that, just over, the division of B, right? So it is your A cos theta, that means a projection, right? Projection of A along B, right? It's a very simple case, okay? Okay. So here is our crucial findings. There is a dot B, that means the magnitude of A, magnitude of B into cos theta, and here is a cos theta, that means the length of the shadow of vector A on the B, the projection of vector A along the vector B is actually A dot vector B by magnitude of vector B, right? Okay. So now just erase all of this thing here and just summarize this case, two line, just a two line is okay. So it is our, if A dot B is actually magnitude of A, magnitude of B cos theta, in the figure, it is a A, it is a your B, it is your A, it is your B, it is a theta, okay. And then another conclusion here, another findings, A dot vector B by magnitude of B is actually your modulus of A cos theta, that is the length of the shadow or projection of vector A along B. Okay. Now erase this thing. Now just encounter our previous lecture, the algebraic representation of the vector, right? Okay. So here, just draw a coordinate system. It is your x, it is your y, and the positive y here is a positive x here, is a negative y here, is a negative x here, right? It is the origin, right? 0, comma 0. Okay. And obviously, if you scale these two axes, the x-axis and y-axis, it's limited 1, so 2, so 3, so 4, so 5. Obviously, it's a 1, it's a 2, it's a 3, it's a 4, it's a 5, right? Now, so many here. So obviously, from our previous lecture, all of you know what is the I cap. I cap means unit vector along the x-axis. Obviously, I cap and j cap is the unit vector along x-axis. and here is the unit vector along y-axis. I mean the positive, right? The positive x, positive y. Okay, so very simple case. Okay, so ultimately it is your I cap, it is your j cap, right? So you can call it is I cap, it is your j cap, right? Okay. So now is in that class, I mean, is today's class, I'll represent dot product, the algebraic sense. I mean the algebraic representation, the dot product. Okay, because the last class I have introduced the addition and subtraction of two vectors with the algebraic representation. Now our turn is just our turn to represent the product rule in the algebraic sense. I mean the algebraic representation of two vectors. Right? Okay. So first of all, a simple thing. If it is just recall our this equation a dot b, the dot product of vector a with b, what will happen? That means a dot b means magnitude of a into magnitude of b into cos theta. Okay, so very funny thing. Obviously, so if you just introduce here instead of a, you just I cap, and instead of b is the another I cap here. Then obviously just place instead of a is I cap. So modulus of I cap, instead of b just place the another I cap. Okay, that's very simple. Just instead of a, just place it I cap, and instead of b, just place it I cap here. Actually, I want to calculate what is the value of I cap dot I cap, right? What will be the value of I cap dot I cap? Okay, so just instead, I mean, just place I cap here instead of a, and just place I cap here instead of b. Okay, then, okay. So it is the angle theta is actually the angle between A and B. So obviously here is a means I cap, here is a B means I cap. Now what will be the angle in between I cap and I cap? So obviously it is the I cap, right? It is the I cap. So if it is the I cap, then it is the I cap, obviously. Then what will be the angle in between I cap and I cap? 2 I cap. 0, na? Obviously 0. Okay. The 0 degree angle, right? So obviously here is the cos 0 degree. So obviously all of you know what is the value of cos 0, right? It's a 1, right? And as the name suggests, the unit vector, that means the magnitude of the unit vector is actually 1, right? That means it is the magnitude of I cap. You will write 1, okay? So obviously it is a 1 into, there is a 1 and cos 0 means 1. So 1 into 1 that means 1. So obviously I cap dot I cap goes to 1, right? Very simple case. I cap goes to 1. Okay. Okay, and now if you introduce here instead of A the j cap and instead of B the another j cap, then what will happen? Is a j cap dot j cap. Just introduce instead of A the j cap and instead of B the j cap. Then obviously here is a right part of our equation. Instead of A just place j cap and instead of B just place j cap, and obviously the j cap means here is a j cap, is another j cap obviously, and the angle in between j cap and j cap goes to 0, right? So obviously cos 0 here, and obviously the 1 into 1, cos 0 means 1, this goes to 1. The other findings j cap dot j cap is a 1, okay? Obviously, and by our intuition, the intuition tells us obviously the k cap dot k cap goes to 1, right? Okay, so I cap dot I cap means 1, j cap dot j cap means 1, and k cap dot k cap goes to 1. Okay, It's a very special thing here. If you dot a vector, a unit vector with itself, if you dot a unit vector with itself, the result will goes to 1, right? If you dot a unit vector with itself, your result will goes to 1. Okay. Now, what will happen if, okay, just write this main equation. A dot b equals to magnitude of A, magnitude of B, and cos of theta. Then what will happen if the I dot j, right? I dot j. Just replace I hat instead of A dot here and a j hat instead of B, right? Just replace I hat instead of A and j hat instead of B. Okay. Then obviously the right part of the equation will goes to the instead of A just write I hat here, instead of B just write j hat here and cos. And now what will be the angle in between I and j? It is your I hat is a j hat, and obviously all of you know it's a perpendicular, right? And a 90 degree. Okay, so that means a cos 90 degree, theta will goes to 90 degree, the cos 90 degree, and all of you know the cos 90 degree means 0. Okay, this is 0. This is 0 and 0 into 1 obviously is a unit vector. That means, as the name suggests, the unit vector means the magnitude of 1. So obviously it will goes to 1 into 0, and all of you know what will happen. 1 into 0. So obviously it is 0, right? So I dot j goes to 0. Okay. And all of you know from our previous part, I mean the geometric representation of dot product, obviously A dot B means B dot A, that same thing. These two are the same thing, right? So obviously if I dot j goes to 0, so j dot I goes to 0, no problem. Okay, and obviously from our similarity, I dot k goes to 0, k dot I goes to 0, because I, j and k is a unit vector along x, y and z axis, and all of you know these three axes is actually mutually perpendicular. I mean x and y is mutually perpendicular. I mean the angle in between these two is a 90 degree, and obviously is a z axis. So the angle in between x and z is obviously 90 degree here. It is a 90 degree, right? It is a 90 degree, and obviously the angle in between y and z is a 90 degree. Right? So obviously I dot k will goes to 0, k dot I goes to 0, j dot k goes to 0, and the k dot j goes to 0, right? Okay, so it is our very crucial findings. Now I just erase some. Okay, I just erase this figure, and this just I write this type of thing. I mean the I dot I equals to j dot j equals to k dot k goes to 1, and I dot j equals to j dot I equals to k dot I equals to I dot k equals to j dot k equals to k dot j goes to 0, right? Okay. Okay, so these are just the findings. Okay. Now, there is a very crucial findings right now. If it is a I, if it is a j, all of you know from our previous part what will be the value. I mean, what will be the figure of 3 I hat, right? So it is a 3 I hat, right? Because 3 I hat means I hat plus I hat plus I hat. So it is a 1 I hat, it is 1 hat, it is 1 hat. If you just add these 3 I hat, you will get 3 I hat. So it is your 3 I hat, right? And obviously, what will be the 4 j hat? Very simple thing. It is your 4 j hat, right? It is a 4 j hat, right? And it is a very interesting here, which is a, if you divide this 3 I hat with the length of this, just name it vector A, okay? Just name it vector A and just name it vector B. So if the vector A means 3 I hat, right? I just write here 3 I hat. Note the length of this straight line, obviously 3, right? The length of this straight line and the magnitude of vector A is 3. So if you divide the vector A with the magnitude, that means a vector A here, just named this 3 I hat is actually vector A. The magnitude of this vector, the length of this straight line is a 3. And all of you know the magnitude, that means modulus of A. What will happen here? You can cut it 3 and 3. What will left? I had. Okay. Okay. And there is another example here. So if you just write vector B, so what will be the vector B here? Vector B equals to 4 j hat, and if you divide this length of the vector B, the 4, right? The length of the vector B is actually the 4. So the length of your vector B, the magnitude of vector B, then what will happen? The vector B is actually 4 j hat, and the magnitude of vector B will goes to, the length of this straight line will goes to 4. Then you just left j hat. So here is the crucial findings, right? If you divide the vector with its magnitude, if you divide the vector with its magnitude, what will you get? The I hat means the unit vector along A, right? I hat means the unit vector along A, and there is a j hat. J hat means the unit vector along B here. The unit vector along B, right? Because the j hat means the unit vector here along B, because the B is in that direction and A is in that direction. So if you just divide a vector with its magnitude, you will get the unit vector along that vector, right? Because the I hat means what? That direction, unit vector in that direction, the unit vector along the A. And what will the j hat is actually? J hat means the unit vector along this direction. That means unit vector along B. Right? So obviously, if you divide a vector with its magnitude, you will get unit vector along this direction. Right? So these are very crucial findings here. So just I write the findings. If you divide a vector with its magnitude, you will get unit vector along that vector, right? Very crucial findings, right? If you just divide a vector with its magnitude, you will get unit vector along that vector. If you divide a vector with its magnitude, you will get unit vector along that vector, right? So, if you divide a vector with its magnitude, you will get somehow unit vector, just in general name it n hat, along this direction. Basically, n hat is actually unit vector along vector A, right? Because it is a unit vector along the vector, unit vector along that vector. That means unit vector along that vector, right? So these are very crucial findings. Okay. So if you divide the vector with its magnitude, you will get the unit vector along that vector. Okay. Okay. Let us take another example. This is a very clear. It will be very clear if you just take another example here. It's a minus 1, it's a minus 2, it's a minus 3, it's a minus 4. So obviously this vector will goes to somehow vector C, that means a minus 4 I hat. Right? All of you know it's a minus 4 I hat. And what is the length of this line? It's a 4, right? It's a 4. Because the length couldn't be negative, right? The length is always positive. So the length couldn't be negative here. The length is 4, right? It's a 4 unit. Just divide vector C with its magnitude. What you will get? Vector C means the minus 4 I hat by the length of this vector 4. You are just left to minus I hat. Obviously, it is a minus I hat and it's a unit vector along that vector C because it's the direction of vector C. And if you just divide vector C its magnitude, you will get minus I hat, I mean the unit vector along the vector C. Right? It's a very simple case. Okay. So it is our number 3 crucial findings. If you divide a vector with its magnitude, you will get unit vector along that vector. It is a general consideration. If it is a vector A divides the vector, I mean the magnitude of A, you will get n hat. N hat means unit vector along the vector A. Okay. Okay. So obviously these are, if you just jumble here and just cross multiply, you will get vector A is a magnitude of vector A and the unit vector along the vector A. Right? So if you want to know what will be the vector A, so it is, you can just calculate the magnitude of vector A and the product, and just product with it with a unit vector along vector A. Right? So the vector A is actually the magnitude of A into just a product the unit vector along A, right? Along A. I mean, if you want to know what will be the vector A, so just products the magnitude of A with its unit vector along A, right? You will get the full vector A. Okay. Okay, fine. Now I'll erase all of this thing here. Okay, all of this thing here. Now it is our turn to represent the the magnitude of A. So actually, just erase this thing. Okay. Oh no. Okay, so just forget it. I mean, I dot I means 1, j dot j means 1, the k dot k means 1, and I dot j 0, j dot k 0, I dot k 0, something like that. Okay. Now, if I draw a coordinate system here, it's a 0, comma 0, it's a 1, it's a 2, it's a 3, it's a 4, it's a 5, it's along the positive x axis. It's a positive y-axis here. It's a 1, it's a 2, it's a 3, it's a 4, it's a 5, and then so many here. Okay. So just think, if A dot B equals to magnitude of A into magnitude of B into cos theta, then what will happen with A dot A, right? What will happen with A dot A? Just place instead of A is a A and instead of B is a A. Okay. So obviously there will be A, so fix it, and instead of B just place it A, instead of B you just place it A here. So obviously here it goes A, and what will be the angle with A and A? 0 degrees, because if it is a A, it is another A, so the angle in between A and A will goes to 0, right? So obviously cos 0 here. Cos 0 means 1, so it's the modulus of A, I mean the magnitude of A, I mean the magnitude of A whole square, it's the A dot A. Then the magnitude of A will goes to root over A dot A, right? Root over A dot A. Okay. Okay, so now if you have a vector like 3 I cap and you have a vector like 4 j cap, then what will be the value of 3 I cap plus 4 j cap? I mean, what will be the diagram of 3 I cap plus 4 j cap? All of you know how to add this thing, right? 3 I cap plus 4 j cap means if you just translate this 4 j cap from here to there, just connect the initial dot and final dot, you will get 3 I cap plus 4 j cap, right? Okay, and all of you know from our Pythagoras theorem, the length of this vector, I mean 3 I cap plus 4 j cap, will goes to 5, right? It's a 5 unit, because it's a 3, it's a 4, so it's a right angle triangle. Just use your Pythagoras theorem, you will get a 5 unit here, right? That means it is a root over 3 square plus 4 square, right? Okay. So if it is a vector 3 I cap plus 4 j cap, the length of this thing, the length of this vector will goes to this 3 square plus 4 square, right? Okay, 3 square plus 4 square. So if it is a vector somehow like 3 I cap, and the vector A, for example, the 2 I cap plus 5 j cap. So obviously the length of the vector A, means the magnitude of A, will goes to 2 square plus 5 square and whole root, right? Okay. Okay, so if it is the length of vector A, then it is a 3 I cap plus 4 j cap. It is a vector A, or it is a vector A, so just name it vector B, right? The vector, if the vector B is 3 I cap plus 4 j cap, the length of the vector B goes to root over of 3 square plus 4 square, right? This is a 3 square plus 4 square. This is a 5 unit. And obviously the same, just a similar process here, similar procedure. If the vector A is represented as 2 I cap plus 5 j cap, the modulus of, I mean the magnitude of A, will goes to root over 2 square plus 5 square. Right? Okay, so now these are end of the classes, and in next class I will just introduce how to calculate the magnitude with the dot product, relation with the dot product with the magnitude, and the components, and the x components, y components, z components of vector, and then cross product of the vector.